Welcome to This Explainer. Today, we are tackling a massive and honestly pretty expensive question for a lot of homeowners. With electricity prices surging and this huge push to cut home emissions, it's really no surprise that people are looking for better ways to heat their homes. But look, if you live in a climate with severe winters, making a drastic change to your HVAC system, well, it can feel like a massive risk. So today, using the absolute latest source material, we're going to break down exactly what you need to know before you make a decision.
Okay, let's dive right in. Because if you live in a place like Illinois that regularly drops well below freezing, you have likely wrestled with this exact anxiety. We all know that heat pumps are, frankly, incredibly efficient in mild weather. But the core question for so many homeowners remains incredibly simple and incredibly urgent. Do they actually work when the bitter cold sets in? Can you really trust this technology to reliably heat your home during a brutal Illinois winter? Or are you literally going to be left shivering when the next polar vortex hits?
Well, the short answer to that anxiety is a resounding yes. They generally provide totally effective heating throughout the colder months. But the real story here, and honestly the whole reason we're doing this explainer today, is that your comfort and, more importantly, your wallet rely entirely on proper preparation. How well these systems perform and how much they actually cost you to run depends heavily on system design, accurate sizing, flawless installation, and having an airtight plan for the absolute coldest days of the year. It's really not just about buying a box and plugging it in. Let's kick things off with Section 1, Heating in the Cold, and how the technology actually works. To understand how these machines actually survive and thrive in an Illinois winter, we first need to look under the hood at the refrigeration cycle. When we think of heating, we usually think of burning something, right? Like gas in a furnace to create heat. But a heat pump doesn't actually create heat, it moves it. Think of it like a giant thermal sponge. In the winter, it acts as a sponge outside, soaking up ambient heat from the air. And yes, incredibly, even when it feels absolutely freezing outside, there is still heat energy out there. It soaks that up and then squeezes that heat out right inside your living room. Now, obviously, the laws of physics still apply. While the system's efficiency does dip as temperatures plummet, it absolutely continues to deliver useful heat to keep your house warm. You see, Illinois winters vary a lot by region, and when that occasional deep, deep cold spell hits, the pump just has to work a bit harder to extract that ambient heat. This lowers its efficiency, sure, but make no mistake, it is still working and it's still pulling useful, warming heat into your home. Moving on to Section 2, sizing and installation matter. Consider this your reality check. You see, the equipment itself is really only as good as the physical conditions it operates in. When it comes to sizing your system, think of it like Goldilocks. Guessing is an absolute disaster. Go too small with an undersized system and you're going to be shivering while paying a fortune for expensive backup heat. But on the flip side, if you think bigger is always better, well, an oversized system is just as bad. It causes major inefficiencies and this rapid turning on and off that literally destroys your parts. It has to be just right. So nailing the installation means ignoring slick marketing and demanding a strict, math-based heat loss calculation from your contractor. Absolutely no guesswork allowed. From there, it's really a team effort. You need low temperature controls communicating seamlessly with your backup heat and a home wrapped in good insulation to trap all that heat you're paying for. Add a clean, unobstructed outdoor unit, accurate refrigerant charges, and well-sealed ductwork, and boom, you are setting yourself up for success. Which brings us to Section 3, your backup heat strategy, the contingency plan. Because let's face it, even with a perfect install and incredible insulation, Illinois winters have those bitter, bone-chilling cold spells. And that brings us to the balance point. Understanding this term is absolutely essential. The balance point is the exact outdoor temperature where your heat pump essentially says, okay, I need some help here. Below this specific manufacturer-defined threshold, your built-in electric resistance or backup source takes over to keep you from shivering. Knowing and setting this balance point correctly, that is exactly what keeps your home comfortable without sending your utility bills straight through the roof. Choosing the right backup depends entirely on what you already have in your home. This sort of hybrid approach, where you keep an existing gas furnace for the absolute worst days, is incredibly popular right now. Why? Because it keeps your bills totally predictable and really removes the risk. On the other hand, if you're doing a full replacement, installing a highly efficient new backup, along with some careful thermostat programming, ensures smooth performance without those frequent high-cost heating spikes.
But hey, what if you want to rely way less on that backup? Well, if you're willing to invest in premium technology, you need to look for cold climate heat pumps. These things are specifically engineered for places like Illinois. They feature improved compressor controls and optimized defrost strategies to actually keep ice off the outdoor unit. This better low ambient operation means, yeah, they might be a bit more expensive up front, but they drastically reduce how often you actually need to rely on that supplemental backup heat when a cold snap hits. A real game changer.
All right, let's wrap things up with Section 4, Steps Before You Switch, the Action Plan. We know the tech works, and we know the pitfalls, so before you spend a single dime, you've got to follow this exact checklist to protect your wallet. Step 1, get a whole home heat loss assessment to estimate exactly what your unique home needs. Step 2, pair the new system with weatherization and insulation improvements. Seriously, even the greatest heat pump on Earth is going to struggle if your home is leaking air and demanding constant heat. And finally, step 3, confirm how your installer will set the controls for your supplemental heat. Having a transparent discussion right up front about winter operating expectations, that is the difference between an amazing cost-saving experience and total frustration. Ultimately, the data proves it's really not a question of whether heat pump technology works in Illinois. It absolutely does, especially when you use cold climate models and the right setup. The real question is whether you've done the homework to make it work for you. Have you done the insulation work? Have you demanded the right calculations? As extreme weather kind of becomes our new normal, you have to ask yourself, is your home actually prepared for the future of heating, or are you going to stay stuck in the past? Thanks so much for joining me for this explainer. I'll catch you next time.